Oh, hi, welcome to the Shiko Math Practice Lab, learning through practicing. And we are practicing that this is our practice number 9 and in the unit of limits, how to find the limits. So this is the second part of the practice number 9 is try to practice how to find the limits when the x approach to infinity and how to find the horizontal asymptotes. So we have a complete, a lot of problems from the previous videos here, right? So let's take a look. Let's go back to our worksheets here. All right, so now we start. Okay, so let's go ahead and take a look here. So for here, this is the x approach to the negative infinities here, right? So be careful that this is a negative infinity. All right, so now when you try to do here, so first things here, take a look, the x squares, right? So if it's negative infinity, you squared it, what is this going to be? A positive infinity, correct? Then for the x to the 7 is the exponents is an odd number. So if you like do the x to the 7 powers, so what is this number going to be? This is going to be what? Is negative infinities, right? So we came out with infinity minus infinity. So how do we do this? Infinity minus infinities. So here we don't know, right? So it's indeterminate. So let's take a look at these ones here. So let's see here, this is x approach to the negative infinity. So how about let's, let's factor, okay? So how about let's factor the x to the 7 out, okay? So when you factor the x to the 7 out, what is the first term we have left? Here, this is x to the what? X to the 5th, right? Okay, and then plus 2 here. Okay, so now let's take a look again. So when the x approach to the negative infinities here, right? So then this turns here, because your denominator will become to the negative infinity, so the whole this term will going to approach to what? Will approach to zeros, right? So now if this term approach to 0, then the whole inside here going to approach to what? Going to approach to 2. And then you have these terms here, x to the 7, when you approach to the negative infinity. So what is this term going to approach to? Still is negative infinities, right? So what is your final answers here? The final answer will be the negative infinity, because 2 times the negative infinity still is negative infinity. Okay, so now let's take a look at this ones here, the number 34. Okay, so number 34 here. So this is the x approach to the negative infinity. Okay, so let's take a look here. This is x to the 6th. So the negative, this one will approach to what? Positive infinities, right? And this one's here, this will approach to the positive infinity, because the exponents are the what? Are the even numbers here, right? So what is the exponents here? This is 4, and this, I'm sorry, this is 6, and what is the exponents here? This is the 4. So we know the 6 is bigger than 4. So when the 6 is bigger than 4, what is the limit? Going to be the will be what? Be the infinities here, right? Because after you give the 4 to the bottom, you still, the top, you still have x squared left. So x squared, when you approach to the negative infinity, still is a positive infinities, right? Or if you're not sure, you can always do like this. Okay, so if you're not sure, you can always do like this. You say the limit x approach to negative infinity, like we talked before, you can factor. So if you factor this one out, you will have 1 over x4 plus x2. Then here you will have x4, 1 plus 1 over x4, right? And now in here, then we know this one going to equal to 0, this one going to equal to zeros, right? And these two, they can cancel out. So you have 0 plus infinities here, right? Because then this one here is a square, so that is why your answer is a positive infinity. Okay, now number 6. Number 6 is a very interesting province here. And the number 6 here is not a polynomial anymore, it's exponential function. So we have the e to 3x and the minus e to negative 3x. So remember e to negative 3x by the exponents rule, we know this is e to what? 3x, right? Okay, so now how do we do this type of the problems here? So let's see here, the limit to x approach to infinity. Okay, because like in here, right? So if you take a look at these terms here, when the x approach to infinity, what is this term going to approach to? Will approach to zeros, right? So we want to have these good terms there. Okay, so now let's take a look for these ones here. One thing you can do, you can factor the 3x out. Okay, so if you factor the 3x out, what is the first term you have? You have 1s, right? So you have 1, then what is the second term? The original was negative 3x, you take the e to 3x out, so what is here? 6x, negative 6x. So the same thing, the bottom here, you can do 3x out, then this is the 1 plus e. The same way, this is negative 3x, so it's negative 6x here. Okay, so now this one is cancels, right? Then when the x approach to infinity, the e to the 3x, 1 over e to the 3x approach to 0. So I know what is this number approach to? Approach to 0. What is this number approach to? Approach to 0. Okay, so what is the final answer? We only have 1 minus 0, 1 plus 0, so it's 1 here. Cool. Okay. So now the same way here, let's take a look here, the number 37s, right? So the number 37s here, this is the same way. So you see the highest powers here is EX and the highest powers here is EX. So by the, like we say, that means these two, they are running what? They are running at the same speed, right? So similar like the binomial, so we know this limit is negative 1/2. All right. If you don't feel comfortable doing that, so like we say, you can say, if you cannot see that, you can always say, okay, I'm factor the EX out, right? So when you factor the EX out, what is here? So this is 1 over EX. Then you have minus 1. Then you factor the EX out. What is here? You have 1 over EX plus 2, right? Then use the same rules. I know when x approach to the infinity, this term going to approach to 0 because the denominator getting pretty big. This term will approach to 0. And these 2ex, they can cancel. So what you have here is negative 1 over 2. That's why you can get a negative 1/2. Okay, so now the next one's here. Okay, so this is the sine square x. Okay, so we know when the x approach to 0 and x approach to infinity, so what happens here? This is x approach to the infinities, right? Then I know my denominator approach to what? Approach to infinities, right? So it's infinity plus 1. But now we talked before, when x approach to 0, sine function is something like sine function is something like this, right? So when x approach to 0, so because like they're going to jump up and down between 1 and negative 1, so you will say, oh, the top is not defined. Well, it's not defined, but it is running around between 1 and negative 1. So in here, when your denominator get bigger and bigger, so this is so big, it doesn't matter here, right? So Now we know this limit is going to what? This limit going to approach to 0. That's by just observing that. Okay, so how do I physically prove it? All right. So that's why we need to use our squeeze series here. We know the sine x doesn't matter. The sine x is always between 1 and -1. So now you have a sine square x. If you squared it, it's always between 1 and the what? And the 0, right? Because you squared it. Okay, so now you times, you have here, this is a sine square x. Then you divide it by x squared plus 1. So it's always be, so you divide it by x squared plus 1 on both sides here, right? So x squared plus 1. Okay, now you take limits, right? So when you take the limits, now you say, okay, I'm doing the limits x approach to what? X approach to infinity. Because this one's here, this is already approach to infinity because the numerator is 0. So 0 over infinity. And then this one's here, where x approach to infinity, you will have 1 over kind of infinities, right? So this is 0. So see here, it was squeezed by both 0 and 0. So that is why the limit x approach to infinity sine square x squared plus 1 is equal to 0, right? So it's very important. It's kind of like the different than what we did before, okay? So be very careful here. Okay, let's take a look at number 40s here. So let's say the x approach to 0 from the right-hand side. Okay, so let's take a look at what is the natural log x here. So we know the natural log x is a function like this, right? So this is kind of like the natural log x here. This is ln(x). So when the x approach to 0 from the right-hand side here, if you trace your function, so what is this one going to trace to? This one going to approach to the negative infinity. Am I right? All right, so now the whole functions here, you will have a tangent, arctangent to the negative infinity. So from the trig function, the inverse functions, I also know, the tangent functions here, right? So tangent function is the domain is from the pi over 2 to the negative pi over 2, right? So this is a pi over 2, this is a negative pi over 2. So what angle will give the arctangent to the negative infinities here? Going to be here, right? So go to the negative infinity. So what is the answer here? So this is a negative pi over 2. Okay, so this one is also is a very unique and very interesting type of the problems, right? Okay, so now let's take a look at number 41 here. So the number 41 here, right? So this is the natural log. So when we try to do this type of problem, okay, so if you take a look here, this is x approach to infinities, right? So if you plug the infinity here, so this will be the infinity minus infinity. So it's undefined. But I know the natural log here, I have a good, when we talk about log function, they have such good properties, right? So this is x approach to infinity. So what is the natural log you minus? Is what? You divide, correct? Okay, and then by limits law, we can put the limits inside. Now you see here, right? So what is here? This is the second power, and what is the bottom here? This is the first power, right? So I know the n's here is equal to 2, then the n's here is equal to 1. So the numerator exponent is greater than denominator. So what is the whole distance approach to? Approach to what? Infinities, right? So now I know that my function is natural log infinity. So natural log infinity, what is the value? Is infinity. Get that? Okay. Now let's take a look at this one. So the same things here, if you just plug in x approach to the infinity, you will get this is infinity minus infinity again. So it's indeterminate. Okay, so now we will use the same tricks here, combine the natural log. So it's x approach to infinity. So natural log minus is divide, right? So it's 2 plus x, 1 plus x here. Then by the limit law, you can take the limit inside the function. So this is 2 plus x, 1 plus x. All right, so take a look. What is the power here? What is the power here, right? So what is the power here? The n is 1, and what is the power here? M is 1. So the numerator exponent is equal to the denominator exponent. So the limit will just be what? The constant, the coefficient in front of x. So the coefficients here, this is 1, this is 1. So it's 1 over 1. So what is 1 over 1 here is 1. So the limit is natural log 1. So what is the natural log? What is the natural log 1? We know the natural log 1 is zeros, right? So if you take a look at the, if you take a look at the natural log function, I graphed here, right? So this is the, so here, right? So the natural log 1 is equal to zeros here. All right. Okay, so now let's take a look here. Okay, so this is the more practice about the natural log, because natural log, so let's try to graph it again. So this is our natural log, right? So let's see here, this is our functions, right? Okay, so let's just be careful because the log functions, the domain is greater than 0. Okay, so now let's see here, the x, okay, so here, okay, so the part 1, see here, let's take a look at the part 1. So it's a limit x approach to 0 from the right hand side of the x and the natural log x. Okay, so see here, limit x approach to the right hand side. So this number going to approach to what? Approach to zeros, right? Okay, now let's take a look at the natural log function. When you limit approach to from 0 from the right hand side, you approach from here. So you trace your log, what happened here. So what are you going to get? Negative infinity. So now in here, you have something here, the numerator is 0 and the denominator are going to approach to 0 very fast. The 1 over the infinity going to approach to 0 very fast. So what is the whole thing? The whole thing is going to approach to what? Approach to zeros, right? So this is the one, it's very important. You kind of test your concept about how well you know about the log function. Okay, so now let's take a look at x approach to 1 from the left-hand side here. Okay, this is interesting. So this is the natural log x. Okay, so the same way is here, x approach to 1 from the left-hand side. What is this number approach to? This number will approach to 1, correct? Okay, so now let's take a look here. Now in here, this is 1s, right? Okay, I'm approaching to 1 from the left-hand side. That means I'm approach to from here. Okay, so now you can, so that means your function going to go approach to here, right? So when you approach to here, what is the natural log? Because you're going to from the left-hand side, right? So what is your natural log function going to approach to? You're going to approach to 0. But look at this red one, because this is approach to 1 from the left-hand side. So all here is always what? Even it's approach to 0, what type of the 0 you're going to approach to is always, we call this negative 0, right? It's a little bit less than the zeros here. So now I know in here, right now, because this is always a little bit less than 0, so when they flip it, it's going to be negative infinity. Okay, so be very careful, right? Okay, let's take a look at number 3 here. So if this is a limit x approach to 1 from the right-hand side, f of x, and this is x natural log x. Okay, so the top, right? So the top still stayed the same. When you approach to x from the right-hand side, this is 1. Okay, so now I'm going to, let me erase this color. So the, erase my, that's fine. Okay, so they erased my function, that's fine. So this is my natural log functions here, right? All right, so this looks ugly. All right, so, oh, that's beautiful. Okay, so that's good. Okay, so this is 1. And then right now, let's say, hey, let's approach to 1 from the right-hand side. So I'm approaching to from this one, right? Okay, so if you approach from this one, then you trace your curve. So that means your curve going to go this way, right? So you trace your curve. That means your curve going to go close to 0. So you're going to reach to 0. But look at this red one. Even it's getting closer to 0, but it's always is what? It's a positive or negative 0. It's a positive 0, right? It's getting very close to the zeros here. So what is the answers here? So it will give you the positive infinity. You get that? Okay. So now, so those are the things we need to be very careful when you do that. All right. So those are very good problems here. So make sure you fully understand how do we derive that. Okay. So now let's take a look at the natural log again, right? All right. So they love natural log because natural log does have a very good character. Okay. So now let's take a look at these ones here. All right, so here, all right, so now let's take a look at the first ones here. So let's say limit x approach to infinity, 2 of x minus natural log x here. Okay, so now let's see here, right? So do the side by side here. If limit approach to infinity, so what is this one going to approach to? This one going to approach to 0. Right? Because the x is in the, in the denominator. Then the x approach to infinity, what is the natural log going to approach to? Natural log going to approach to infinity. And then the 1 over infinity, what is this side going to approach to? Approach to 0. Right? So 0 minus 0 is defined or not defined? Yeah, of course, it's defined. So it's 0 here. All right? Okay, now let's take a look at part B here. So it's a limit x approach to 0 from the right-hand side. This is a 2x and the minus natural log x here. Now let's take a look here. All right, so these numbers here, limit approach to 0 from the right-hand side. That means the whole thing is going to approach to what? Approach to the positive infinity because it's a little bit bigger than 0, the denominator, right? Okay, now here, when take a look here, for these ones here, right? So when the limit x approach to 0 from the right-hand side, that means you approach to 0 this way. So if you trace your function, what is your function going to? So this one going to go to the negative what? This will go into the negative infinity. Am I right? Okay, so this is going to go to the negative infinity. And then the whole thing's here. Okay, so take a look. If this is go to the negative infinity, so what is the whole thing's here going to approach to? Approach to 0, right? Okay, if this is approach to 0, so this is infinity minus 0. Is that defined or not defined? Yes, what is defined? So what is the values here? Is the infinities here. Cool. All right. So now let's take a look at the other ones here. So make sure you fully understand those concepts, right? So this is x approach to 1 from the left-hand side. Well, let's take a look here from the left-hand side. Okay, so then in here, the one from the left-hand side will be the 2x minus 1 natural log x. All right, so this term is easy from the left-hand side. This one is equal to what? This one going to approach to 2, right? Okay, so now let's take a look here. The natural log 1 from the left-hand side. Okay, so that means you approach to 1 this way, right? We did that in the previous ones here. So this one's here, and then you will see here, here, right? So you approach from the left-hand side, it's going to approach to 0, but going to approach to what type of the 0? Negative 0. Am I right? If you approach to negative 0, then, okay, then the whole thing's here, going to approach to what? Negative infinity. Then, all right, so you still have one negative sign here. So what happens here? So this will be equal to the 2 negative plus positive infinity. So what is the 2 plus positive infinity? Is going to be infinities here. All right. It's very interesting. I really like those type of problems. So the part of this here, let's take a look. It's a limit x approach to 1 from the right-hand side, the f of x is here, right? So so I need to write the f of x, just write down the function. Okay. So this is the function is 2 of the x minus 1 over natural log x. Okay, so the same way, the x approach to 1 from the right-hand side, this one, no problem, is 2, right? Okay, now the natural log x is here. So take a look at this one here, right? So this one, if I want to, from the right-hand side, that means I'm approaching to here. That means you trace your function, you're going to approach to what? Approach to zeros, right? So this one's here, we're going to approach to 0. What type of the 0? Positive 0, correct? And it's always a greater than. So then the whole distance here, so then the whole distance here is 1 over positive 0. What it will give you? Will approach to the infinity. Okay, so now I can say this is a 2. Hey, don't forget, I still have this negative. Oh boy, gee whiz, I used the wrong thing here. So this is negatives, right? So I still have this negative signs here. So that means the negative times the positive. So it's 2 minus infinity. So what is the 2 minus infinity? Is equal to the negative infinities, right? So those are the problems to try to test to see how well you fully understand, the right-hand side limit, left-hand side limit, and what is depend on the functions here, okay? Okay, so let's take a look at the last topic here for this assignment. It's going to talk about the horizontal and the vertical asymptote. And so let's do a quick review. I think we did that. So the horizontal asymptote is really when you let the x approach to infinity or x approach to the negative infinity. So you see what the y values approach to, right? If a y value approach to a number, then we say that is the horizontal asymptote. So what is the vertical asymptote? Vertical asymptote is the x values here, which make what? Which make the denominator equal to 0. Of course, if there's a whole, okay, so you need to factor out the whole. Also, okay, so let's take a look here. So the first one is pretty easy. They say the horizontal and the vertical asymptote. So the vertical asymptote, like we said, is what? Is the denominator equal to 0? And there's nothing I can factor out. So what is the x value? X is -3, right? So x equal to -3. This is one of my vertical asymptote. Okay, so now let's take a look. A horizontal asymptote is limit x approach to infinity, right? So when the limit x approach to infinity, this is 5 plus 4x, x plus 3. As you can see, because both of them have the first power, so what is that means? That means both of them have that powers here, so that will be, the limit we're going to be what? It's a force, right? So going to be 4 because n equal to 1 and the m equal to 1, right? So they both have 4. So I know y equal to 4 is the horizontal asymptote. So in fact, for here, this doesn't matter. So if you approach the limit from the both plus or minus infinity, they will reach the same values here because they have the same power. So it's just a 4, 4 divided by 1. And of course, if you have square roots, all these things, right, we need to be a little bit careful for that. Okay, so now the second one's here. So for this one's here, and typical, if you see here, I would like to basically do a little factor first to see I be able to factor the wholes out. So this is a 3x minus 1, and this is, I think this is x plus 3x minus 1, and I think this is x plus 4, right? And okay, so I think I made a mistake for factoring. So this is what? It's not plus 4. This is this is a plus 1. That's right. So this is a plus 1 here. Okay, so as you can see, nothing I can factor. So the the vertical asymptote is that the denominator equal to 0. So this is equal to 0. This is equal to 0. So what is my vertical asymptote here? Vertical asymptote is x equal to 1/3 and x equal to -1. So now let's take a look, the horizontal asymptote. So like is x approach to infinity, or, you can say both plus and minus infinity. They not going to make a differences in this province here. So this is 2x squared plus 1. This is 3x squared plus 2x minus 1. And then you compare, the exponents. The exponents here, n is equal to 2, m is equal to 2 also. So what is the answer? The limit is 2/3, right? It's just the constants in front. So I know my horizontal asymptote is what? Y is equal to 2/3 here. Right, so this is my vertical asymptote. So all these problems are very similar, and I think it's kind of like, oops, what is that? So it's kind of like the similar type of the problem we did before. So let's take a look. Let's go down here. Well, some reason it would not let me moving down here. Okay, that's interesting. Why? Okay, let's continue. For some reason, I think the Microsoft stopped responding. So that's why I got a little bit of hang up there. Okay, so I think all the others is pretty easy. Let's try to do a couple more. All right, so the one more I like to do is the problem number 50 here, right? So for this ones here, like I say, typical when I do those type of the problems, if I can factor, I will factor first, right? So here I will take this is x squared, then this is x squared. Now I can factor more. So this is 1 plus x fourth, then this is x squared, then this is 1 minus x, 1 plus x here. Okay, so still nothing I can factor out, right? I cannot cancel out with numerator. Okay, so now take a look here. The vertical is you let the denominator equal to zeros, right? So the vertical asymptote is the denominator equal to 0. So I know the vertical asymptote. What is my vertical asymptote? X equal to 1 and x equal to 0 and x equal to negative 1, right? Okay, so now I'm looking for the horizontal asymptote. So when the horizontal asymptote is x approach to the positive or negative infinity. So in fact, here not going to make a difference. You can approach to the positive infinity and you can approach to the negative infinity. They will give you the same answer because it's the x to the fourth, it's the even power. So this is x squared minus x fourth. So when they go to the infinity, see here, right? So here, take a look here. This is the fourth power, this is the fourth power. So I know the exponents here, there's n equal to 4, m equal to 4 also. So what is the limit? The limit is approach to what? The constants in front of it. So here is the constants, it's ones, right? So what is the limit here? So the limit here will be negative ones here. So it doesn't matter, it's a positive infinity or negative infinity because the x force will going to all become positive. So that's what is my horizontal asymptote is y equal to the negative 1. Okay, now let's do one last one here is this EX things again, right? Okay, so the EX things again. So the first, let's take a look. Okay, so I said the limit X approach to the infinity. And so this is to the EX and the EX minus 5 here, right? Okay, so now, like we did before, let's to the EX out. So what is here? This is 2, right? Okay, so if you take the EX out here, what is this one going to be? This one going to be 1 minus 5 to the what? 1 minus 5 to the EX, right? All right, so now in here, then we know that here, the EX and the EX, you can cancel. And then here's a 2. And so in here, then this one here, when EX go to the infinity, what is this one going to go to? This one going to go to what? This one is going to go to zeros, right? Because this bottom going to the infinity, so it's 1 minus 0. So the answers here will be equal to 2, right? Okay, and okay, so for these ones here, we need to be a little bit careful here, right? So these ones here, let's be very, very careful. So let's take a look what happened to the, what happened to the values when the x approach to the negative infinities here. Okay, today the Microsoft just acting on me, so it kind of not respond again. So hope that we can finish this last problem without no issues here. Okay, we are working on the, the problem number 52 here, right? Okay, so we said y is equal to the 2 to the EX and EX minus 5. So we said the first things here, let's try to factor the EX out. So I have a 2 here, so I have an EX, this is 1 minus 5 to the EX. All right, so when the limit x approach to the positive infinity, so this is the EX, this is 2, this is the EX, this is 1 minus 5 EX here. So we know here the EX and the EX can cancel out. when x approach to the positive infinity, this number is going to where? This number going to the infinity. If this number going to the infinity, that means the whole distance go where? Go zeros, right? So that means in here, my limit going to approach to 2 over 1, so it's 2. So this is one of the horizontal asymptote. So now let's take a look at the other one. So when the x approach to the negative infinity, so I'm still be able to cancel out. So I still have 1, 2 over 1 minus 5 ex here. Okay, now let's be very, very careful here. So when x approach to the negative infinity, what is this number going to approach to? This number going to approach to 0. All right. If this number approach to 0, what is the whole this number going to approach to? This number going to approach to infinity. That means in here, my whole thing is going to be 2. The 1 minus infinity still is infinity, right? So it's negative infinity. So what is the whole thing I'm going to approach to? I'm going to approach to zeros here. So that means I have 2 horizontal asymptotes. Y is equal to 2 and y is equal to 0. Be very, very careful this problem here. Now, you know, what is the vertical asymptote? Remember, the vertical asymptote is the denominator equal to 0. So I will set this one equal to 0, right? So I solve for x. So the ex equal to 5. Then you take the natural log of both sides. So x equal to the natural log of 5 here. All right, so this is my what? This is my vertical asymptotes here. Okay, finally, we got a couple times got the Microsoft is not responding. So right now, finally, we'll be able to finish this. That's good. So 52 is a very good problem here because, you know, when we talk about the asymptote, the x has to be approached to the positive infinity and the negative infinity. Some of the problem doesn't matter, right? But this one, it does matter when the x approach to the positive infinity and the negative infinity, then they have a different asymptotes here. All right, that's it. That is the for these sections and how to find the limits when we go to the infinity and how to find the different asymptotes here. All right, that's it. And nice talk to you. Hope this is a help for your homework. Okay, bye. Okay, let me see. I can stop.